Hi, my name is Aditya, and in this video we will be designing WhatsApp. WhatsApp is a very popular messaging service that allows users to send text messages to one another, as well as videos and images. Before we get started, let's think about some of the use cases we want for our system. So we want one-to-one messaging in our system, meaning if you have user A should be able to send a message to user B, and user B again should be able to send a message back to user A. We want our system to have these three different statuses available to each user when they message other users. As an example, if we have user A and user A is sending a message to B, user A should know when his message has been sent. So on WhatsApp, that's denoted by a single check mark. Delivered would mean two check marks. So this means that the message that A sent has been successfully delivered to B, but B hasn't read it yet. And then the red status would be two check marks, but these are blue. So we want this use case in our system as well. We can think about media. So this would be sending pictures, videos, we can think about group messaging as well as another use case. So here we have a couple of use cases. Now let's think about how we can design our system. So the first one we had was one-to-one messaging. So here's how we can think about this. We have user A here, and so this is A, and then we can have user B here, and we have our system here in the middle. So user A will talk to our system and want to send a message to user B. And B should be able to send a message back. So one way we can think about this is by having servers in the middle, which are, so we have, like, let's say this is server 1, this is server 2, and so on and so forth. So what I'm getting at with this is saying that if you have user A will get user A gets assigned a server. So for example, user A will be talking to server 1. So whenever user A wants to send a message to wants to send a message to anyone, user A will first contact server 1. Server 1 will then figure out what server is the other user associated with. So in our example, let's assume that user B is associated with server 2, user A is associated with server 1. So when user A sends a message to server 1, server 1 will have to contact server 2, and then server 2 will send the message back to user B. So here's how it would look. So let's say user A has a message, hi. So this hi gets sent from here to server 1. Server 1 figures out that server 2 is associated with user B. Server B will send the message this way. Then server 2 will send the message to user B. So user 2 will then get hi. So that's how we can think about our system. So now the question becomes, how do we associate, servers with users? So one way to do this would be, having some, like a mapping, for example, where up here we have like a mapping, so this would go from user to server number. So in this case, whenever this user wants to use our system, we do a lookup in this table or in this data store. We can figure out that, okay, A is associated with server 1, so that means the server 1 will take care of user 1. User A. So that's one way to approach it. So every time a new user wants to interact with our system, what we first do is say, hey, let me look at, is there already a server associated with this user? If not, we can randomly pick a server. For example, we can randomly pick a server. We can do something like round robin. So based on the users we're connecting to our network, we can round robin them off. Meaning, like, if we have server 1, 2, 3, and we have other users joining in, the servers, they get assigned or go in a circle. So we would say the first one that comes in gets server 1, then the next user is server 2, server 3, and then we will loop back. So that's how we can assign servers to each user. Let's think about how a user will communicate to the server and how the server would communicate back to the user, right? So typically, if we think about how this request would be sent, right, it would be, for example, through HTTP. So in HTTP, we have a client and we have a server. So in our scenario here, this user is the client. So the client would send a request. So in this case, it would be a message saying hi. The server would acknowledge the request and return a response saying, okay, I have received your message. So that's a typical client-server relationship of how typically HTTP works. One downside of this is that in our scenario here, we have actually a two-way communication going on. What I mean by that is that not only would user A be talking to server 1, server 1 should be able to talk back to user A as well. Why? Because if we have, for example, user C here, user C, and user C wants to talk to, let's say, user A, so C wants to send a message to A saying hello. This message will first have to go to server 1, and then server 1 will have to send the message back to user A. So we need a bi-directional communication in this case. So if we stick with the traditional HTTP approach, what we can do is do long polling. So what this would do is basically each user would at a predefined interval continuously poll the server, asking for any messages that server might have for user A. So what I mean by that is that we have our user here. User A would continuously be polling server 1 for new messages, like every 20 seconds, every minute, or a predefined interval. So it would poll, then wait for a set amount of time, and then poll again to get any new messages. So that can be inefficient, because if no one is messaging user A, then there's unnecessary calls being made from user A to the server, and the server has to just basically send nothing back to user A. So what we can do instead is have something called a WebSocket. So having a WebSocket would allow user A and server 1 to talk to each other and bidirectionally, meaning instead of having a new connection being made every single time user A wants to send a message to server 1, or the user A wants to continuously poll for new messages. by having a WebSocket, the messages can be sent both ways. So let's go with that approach. So now we have that each user will be associated with one server. This server will be responsible for both sending messages on behalf of that user as well as sending messages to that user. As an example, that would mean, in this case, would be if A is associated with server 1, that means A is sending messages to server 1 that A wants to send to other people, as well as server 1 delivering messages from other users to user A. So that's how we can think about our architecture this way. So now we've talked about how to do a one-to-one, one-to-one messaging. We can think about how can we implement like a read, delivered, and sent feature in our system. So as you may recall, each of these denote different stages of what happens after a message has been sent. So going back to our example, as soon as user A sends a message to server 1, that would be denoting a sent, meaning user A has sent a message to server 1. Server 1 will send a message back acknowledging that, hey, I've received your message, and then on user A's device we can show this one check mark. Then what we can do, for delivered, what we can do is that when user A sends a message to server 1, server 1 sends the message to server 2, then server 1 can send a message back to user A saying the message has been delivered. So to recap, what I'm saying is that, let's say we have user A has server 1 as its server, user B has server 2 as his server. So in the send case, as soon as user A sends the message to server 1, that would mean that we can tell user A that your message has been sent. Then when server 1 transfers that message to server 2, then server 2 will send a response back to server 1 saying, yes, I have successfully received your message. Then server 1 can send another message back to user A saying it's been delivered. And for the last step, for read, we go one step even further down. So that would mean that user A sends a message to server 1 sends it to 2, server 2 sends it, delivers the message to user B, and then when user B opens up the application on his phone, and message is automatically sent that goes through this process again. So it would go from B to server 2 to server 1 to user A. So that's how we can think about this use case here, the second use case. So we've talked about having a one-to-one communication system, messaging system. We've talked about all these 3 different statuses within a conversation of messages being sent between 2 people. Let's talk about media now. So media, this would mean that I'm user A. I want to send, for example, a picture to user B. So it would involve the same idea that user A would within the application, user A would upload a picture. The picture would be sent to the server, and we can have a separate storage for pictures. So we can have like this could be an image store, and within the image store we can store information. For example, like let's say, so if we had like a table, this could be an image. The attributes could be let's say name, or we can give it an image ID first of all. So this would be like the metadata, image ID, user ID, size, date, location, or yeah, location is, I think that can be useful. So these are some of the attributes we would be saving of each image that gets uploaded into our system. And then we can also store the actual path. So this could be like the path to where the image is being stored in our system. And we can store images on some sort of file system, for example, like Hadoop's file system. So that's one way we can think about how we would store pictures. We can also think about maybe using like a CDN for pictures to speed up that the load time for users to be able to see other people's pictures. And why can we use a CDN? Because the picture is static. It doesn't change over time. Once the picture has been sent by the user, that picture, it doesn't really change. So that's one way we can be storing pictures within our system. So we've talked about these three use cases. For messaging, for group messaging, the idea would be very similar to it would be similar to how one person talks to another, but what we can do is have like a group server, for example. So a group server here could have multiple. So how the group server work? What I'm saying is that we can have like person C like this, person D, person D, and person E. So they could have person C, D, and E, and they would all be connected to one server. And depending, as soon as they could be connected to one server, and the entire logic of what I explained here could just apply to this. And the benefit of doing it this way would be that because they're in a group and everybody's connected to the same server, the messages that are being sent would be there would be lower latency in sending messages. Why? Because if you think about this case, when you have user A talking to user B, but they're on different servers, you have this inter-server communication. What do I mean by that? I mean that server 1 would have to figure out that user B is associated with server 2, send a message, and then the message would go to B. But if we have a group server or special group servers where as soon as you add people to a group, they all start a connection or a WebSocket with just one server, we get rid of that extra like messages being sent to within among servers. So that's one way we can think about how we would do group messaging. So there's a potential downside with this. What is the potential downside? What if the group has hundreds of people, 200 people, 300 people, and at some point we'll have what will end up happening is that one server wouldn't be able to support all 200 or some number of users being connected to the same server. So what we could do at that point is essentially have multiple servers associated with the same group, and then have all the communication going between two group servers that represent one entire group. So we have that. One thing I didn't mention earlier was that we made the assumption that if you have user A and you have user B, and user A wants to send a message to user B, what happens if user B is not connected to our system? Meaning, user B is, let's say, turns off their phone and is on an airplane, or they don't have internet connection, so they're not connected to our system. In that case, what will happen is that user A will try to send a message to B, but then server 1 will do a lookup in our this map over here, saying, hey, what is the server associated with user B? but then there's not going to be any entry for user B in our data store here. So what do we do in that case? One approach would be that we can have, let's say, an unread table. So we would have an unread table here, and an unread table we can have columns like from to message. So in this way we can store unsent, not unread, sorry, unsent messages. So this would be unsent. So this would be an unsent table, and what we would be doing here is that if you can't send a message immediately, it gets stored in here, and then as soon as user B gets connected to our system, user B will first get associated with one of these servers. After a server is given to user B, then the server will first will query this table, collect all the messages, and then send them to user B. So that's one approach of how we can talk about that edge case. So yeah, that is how we can think about designing WhatsApp. Thank you.